So now that we have the exited flag to have the right base, we can use then the lift function coming from the caret package to get the lifts, which is what we are interested in. We're going to call it chorn lift, and we're going to use the lift function for that. And the lift function needs two things, and it's a y variable, the response. We're not going to use the $sign because we're going to use the data is equal to actually parameter. So we're going to just say exited, and then the next thing we need is we're going to use it as a model predicted by the propensities. So we're going to use the data is equal to sorted propensities, and that's enough to give us the lift. Now let's take a look at what we have inside that object short lift, and we have a few things. We have a data, so that is every single observation on this data set with the calculated lifts. And we're gonna for now ignore these other objects. So let's print, for example, the first 20 observations on this short lift data object, and we're gonna say 20 observations. And a few things that you're getting from this data set is you're getting, first of all, the COTS, and COTS stands for cutoffs. So if you use the cutoff of 1 on the validation data set with the propensities, then we would want to know how much lift we get, how many ones are we capturing, how many customers who short, and things like that. So remember, we have this data set here, which is the sorted propensities. We said that the highest propensity is 32, so we are not going to get anything if we set a cutoff of 1. So that's the reason why this observation right here sometimes, and most of the times, doesn't make a lot of sense. So for now, let's think, well, what if we made the cutoff to be 31? Then that would give us this sample. In other words, let's look at it in Excel so that it's easier to visualize. So that would be the cutoff of 32, 17%. So that would be this little sample here. Okay. So things that we're interested in this is, well, in this case, we're just capturing, we just have only one customer who's short out of the 5 that we have. So again, our model is not is giving high propensities to customers who actually did not short. So let's explain how's the lift calculated for this particular points. But first, let me give you what the columns. So this is cutoffs. Events is the number of ones that we have if we use that particular cutoff. That would be the number of observations that we see. So again, we said that this would be 5 observations. So that was what you see here, 5. We have sensitivity and specificity under those numbers, under that particular cutoff in here. The event percent, so that would mean the percentage of ones that you have in this little sample of 5. And the next thing that we see is a cumulative event, and we are interested mostly in this column here, which is the lift. Let me give you another example. So we have here, let's select the first, let's say 10 observations. Okay, that would be the cutoff that we would get. In this, selecting the first 10 observations that we would get is 5 and this 5. So that's what this is, our cutoff, 31.61%. All right, we only have 2 customers who short out of the 10. So let me explain what the lift is. Okay, so if the formula for lift, and again, let me say it here. Lift is equal to the proportion of ones in the sample divided by the overall proportion of ones. Okay. Now we need to get the overall proportion of ones in this data set, and we can do that using the table function. And let's take a look at that exited. So we want to see the overall propensities, or proportion of ones. We have 514 out of 2,700. You want to take a look at the prop table of this, and that should give you the percentages. And again, if you wanted to do that manually, that would be okay. So that's the overall proportion of ones, 19%. But at this cutoff point, we only have just 2 ones. So in this little sample that we see here, we only have 2 out of the 10. So really we're looking at the lift to be, well, I'm just getting 2 ones, 2 customers who shortened out of the 10. And that only is 20%. And we would expect randomly to obtain 19%. So that's really not very different than random. So how much different it is? So 20% compared to 19%, that gives me a lift of 1.05. And this is what you see right here. And again, just for rounding errors is different. The last digit is different. But basically what we have is that we're not doing very different at random. Randomly, we would expect only 19% of this little sample to be ones, and we get 20%. So we got actually the same thing. We got 2 out of 10, and we were expecting, well, almost 2 out of 10. So what this tells us is that our models are actually doing a lot better than random. And that is the consideration that we need to do when we do propensity ranking. Now we can look at, again, this will change according to the observations, but if we wanted to send our offer, let's say our $200 gift card to the customers who have, to the top, let's say 200 customers, and we're going to say 201 here because the first observation doesn't have any values in there. If we wanted to send that $200 offer or gift card, then that is going to tell us how much lift we would have, and that would be 1.13, which is not too much. So and again, this probably didn't print all of the observations, so let's just think, and this is only printed 100 observations here, but so at 100 observations this is 1.14, so that doesn't give us a lot of lift compared to random. So if we randomly sent the gift card to 100 customers, we would be almost doing the same thing that the model is doing. So that is what we get with the propensity ranking and the lift.